I'm James Johnson, and you're watching Niagara Pro Tips. Welcome back to this multi-part video on all things BQL. If you haven't taken the opportunity to watch the first video in this series, I would suggest doing so. It covers the basics of BQL, how to use the help in the Workbench client, and how to navigate the Java documentation to understand what methods can be used with BQL. In this video, we're going to focus on the actual BQL select statement and dig into parts of that, including the extent, the projection, and the predicate. This might look a little bit intimidating, but this is designed to show the full syntax of a BQL select statement and have it kind of color coded to break down the various portions of the select statement, the clauses, and we're going to go through and talk about each of these. To start off with, we're going to talk about the base ord and the extent, which are highlighted in yellow in that top line to indicate their position in the select statement. And the base ord and the from clause, or the extent, they work together when the BQL engine resolves that select statement, and it determines the general set of objects that will be returned in the result. Now, I mentioned before that we can query both the station space, the alarm, and the history space. So specifying the extent will vary a little bit depending on which space we're querying. In this case, we're talking about the station space. So in the first example, you can see highlighted in blue, the base ord is the BACnet network. That's limiting the scope in the station of where this query will be processed. Then the extent starts with the keyword from in orange, and that says from, and it's a type spec. So I'm saying I want to go search under the BACnet network for any control points. It's also possible that you can specify multiple types in the extent when we're checking for component type specs from the station. You do that just as in the second example by using a comma and then specifying the other type spec. It's important to understand that when you search for a type such as control point will include these subclasses. So if I search for control point, that will include all the Boolean, enum, numeric, and string points and so forth. If I want to search for a specific type of control points, that's where I would pick a specific type spec that's more specific there than the generic control point. It's also worth noting that the BQL query builder has some limitations, and we'll see this as we go along. In this case, the BQL query builder only allows specifying a single extent from the station. So in the file menu, you can go to File and Open and Query. Now, I do need to be connected to a station for this to function, so I'll just connect to my Greenbrier station, go to File and Open and Query, and this opens up the BQL query builder. Remember, in the previous video, I mentioned the Find section is where we specify the base ord, here on the left where the magnifying glass in this in-field editor is, and the extent over on the right side here where this type spec selector is. And if I just leave the selection at config and then perhaps select control point, all I'm doing is leaving the base ord at the root of the station and saying I want to go find control points in the station. When I click OK, that will go find all the control points in the station. We can see there's 700 results here in this collection table. And if I look at the URL here at the top, we can see that the base ord is the root of the station, and then the pipe symbol, and it's running the BQL statement here, BQL select. And for now, we're just using an asterisk for the projection. We'll talk more about that in a few minutes. And we can see the extent here is the keyword from and control point. Now, you can also see that by going to File, Open Ord, and the shortcut for that is Control L. And that opens up a field editor which shows you what the ord is that the Workbench client is currently viewing. So this is another way to look at it, sometimes a little bit easier with the Control L dialog. If I go back up to File, Open Query again, and I change the scope to now look under the BACnet network, for example, and I'm still looking for control points, notice now I only find 609 things. So the extent in this case is the same as the previous query, but I've changed this base ord to provide more finite scope in the station, which is limited the results that are being returned. So the base ORD works in conjunction with the extent to come up with this working set of objects here. Now, if I wanted to be more specific about that type of component that I wanted to query for, instead of control point, then I could select, say, numeric point for my extent here. And the BQL query builder does have this nasty habit of resetting the base ORD. It keeps the extent choice, but it does reset the base ORD. So I'm going to go ahead and select the drivers in the BACnet network again here. And now you'll see that it's narrowed down to 339 rows in this case. So I've narrowed down to more specific types of control points. And remember that anywhere in the station, we can right-click on a component and choose Views, and then go to the Baja Doc Help link. This will open up the Java documentation on that component. In this case, it was specifically the numeric point type that it's coming up with. And remember, there's different subclasses, like a numeric writable, for example. Numeric point is read-only. Numeric writable is a writable numeric point that's in the station. So if we wanted to search for numeric writable points in this case, I go to File, Open Query again. And again, I'll reset my base ORD still to the BACnet network. And you'll notice that there's some common types here that you can pick from for configuring the extent. And you can see in the ORD up here that it actually doesn't just use numeric point, but it does put the type spec, control module, numeric point. But we only give you a few items here which we think are common things that people might be searching for. So if there's different types that you want to search for other than these standards, all you have to do is choose custom type. And then in this field editor, you'll see now it changes to a type spec selector where you can pick the module and then you can pick the type. So I'll select the control module, and then I can look for numeric writables, and we can select, instead of numeric point, we can select numeric writable as the type spec that we want to search for. In this case, it takes me down to 213 items under the BACnet network, which are control numeric writable type components. Again, just emphasizing that there are some limitations. When we look at the query builder, there is no option for me to select multiple types here, other than looking at a more abstract class like a B control point from the control module, where that encompasses multiple subclasses. If I wanted to get more specific about or use multiple types in my extent, this is where you would be manually typing this in. So this is something that the query builder itself does not support. So for example, I could put a comma and then control : Boolean writable. Maybe I want to search under the BACnet network. This is my base ORD. I'll search under the BACnet network, and I submit my BQL query for both numeric writable and Boolean writable points. When I hit OK, we should get more results. Actually, I guess I don't have any Boolean writable points under the BACnet network. They're all just Boolean points. So let me change this. Instead of Boolean writable, I will just say Boolean point here. So we do have numeric writables, and we have some enum writables here related to occupancy and temperature set points, but all my Boolean points are just statuses like cooling stage, heat stage, and supply fan, so that none of those are writable. So 213 writables, and then it goes up to 359 when I include the Boolean points in there as well. Okay, so for the station space, the extent is always a type spec, and we can specify multiple type specs potentially in the extent there. Now, let's talk about the extent for histories and for alarms. And when we're using BQL queries for histories, you're going to see that there's really kind of two syntaxes that we can support. One uses the keyword from, so we're going to set the base ORD to history, and then the keyword from will then specify the history ID that we want to query from. The other option is that you kind of combine the base ORD of the history space with the history ID prior to the BQL select statement, and that base ORD gives us the extent. So we don't have to put from in the history ID then. And there's some reasons why we might want to do that. We'll see that a little bit later when we get into talking about some predicates and things of that nature. There's also an extent that is for the history database itself, which is from sys.histories. And this will show you a lot of information about all the histories in the station's history database, including histories that have been imported from the Niagara network or the BACnet network or file network or other mechanisms to import those histories into the Niagara station. So it'll include information like the time zone, the source of the history, where it came from, what type of record it is, the schema, and so forth. I'll show you what that looks like here in just a second in the Workbench client as well. And then lastly, we also have the ability to run a BQL query against the alarm database. And in this case, our base ord will be the alarm space. And there isn't any extent to specify with the from clause because there's only a single alarm database table. So all you have to do is just say alarm and then BQL select and then whatever projection. In this case, we're still sticking with the basic projections. So taking a look at that, back in my station again, when I go up to file and open query, in the find section where I've been setting the base ord in the station or the config space, we can also select the history space here. And we'll see if I pick a specific history and hit OK, then OK again, and this will query that history, and we'll see the query here in the URL bar. So I can see in this case, it's the base ord is the history space, and it's specified the history ID of the history, and then it's just a BQL select statement with a standard asterisk for the projection currently. We can also change that syntax like I was showing you on the PowerPoint slide. So I can take and highlight the history ID portion of this, and I'll cut that out and go to the end, and I'll add the keyword from, and then paste the history ID in there at the end of the ord. And that returns the exact same results for me, but it's just two different syntaxes that are supported. Again, we'll talk about some reasons why with the projections and predicates, why we might prefer one method over the other there. There's also the from sys.histories. This is not something that you can do in the BQL query builder, but you can certainly do this in a bound table or just with the open ord dialog here, and I can tell it that I want to do a BQL query against the history space where the extent is from sys.histories. So what we'll see here is there's an ID for each history, and these all originated from this Greenbrier station, but this would include any histories that were imported from Niagara stations, BACnet devices, relational databases, file networks, and so forth. It shows the source, meaning where in the station did the thing that generated the history come from. So it can be a Niagara history import or an actual history extension. You'll see the time zone, and somewhat importantly, I would say here is the numeric trend record or audit record, whatever the type spec is for the record type, and then also the schema, which is telling me what are the columns that will be in the data set that's returned, and what are the names of those columns, and what are the types of those columns. Generally speaking, we'll see these are going to be timestamp will be a Baja Abs time, trend flags. We have our history module trend flags. The status will be the Baja status type, and then the value is going to vary depending on the type of trend. If it's a numeric, it'll be a Baja double. If it's a Boolean, it will be a Baja Boolean, obviously, or a Baja string or a Baja enum and so forth for the type of value. And things like audit history, security history, they're going to have a little bit different schemas. But this also shows you the capacity, the full policy, and interval, and things like that as well. So this can be useful just to try to help look at how all your histories are configured in a database and a station. All right, we can also query that alarm space, right? So if I go back to File, Open Query, and on my base ord selector, instead of picking the config or a history here, I can select the alarm space. And when I do that and I submit the query, what we'll see is that the results are information from the alarm database for all of the alarm records that exist. And just like anything, we can get more specific about the information that we want to see. But again, it's just the base ord is the alarm space, and there's no from or extent to specify because there's a single table for the alarm database. All right. So now we want to get into talking a little bit about the projection, and that's how we specify the data that we want to see in our result. And this is the projection. And so this comes directly after the select keyword in the statement. And this will be a comma separated list of expressions, column expressions that we want to see in the result. And column expressions are evaluated against the object that's returned for each row. So the extent of the query, if it's against the station space, is saying this is a numeric point or a control point that we're looking for. So all our expressions will be resolved against that object that is that row component. If it's a history, it'll be whatever type of history record it is. If it's the alarm database, it will be a B alarm record. So most frequent type of expressions I would say is probably a path expression, something like out.value or parent.name or things of that nature. However, you can also use scalar functions and aggregate functions, which we haven't talked about yet, but we'll cover those in the next video. And it can also be arbitrary expressions such as math, showing in this bottom query, such as out.value times 100 or simply 1 plus 2 as 3. With the projections, there's a couple of special use cases, and you've already seen one of those use cases, which was the asterisk or wildcard character there after the keyword select. And whenever you use the asterisk character, what that does is it tells the framework to return the get slot path method, saying what's the slot path of that component for the row. The toString method, which is what the developer wants you to see as far as information about that object. And then also it will tell you the value of any of the properties that are defined on the class or on the superclass. There's also a couple of special cases of using either a blank projection or the keyword all. So in this case, in the first line in the middle example there is no asterisk or any characters between select and from other than a space character. So that's a blank projection. And the second example there has the keyword all between select and from. Both of those will tell the engine, the BQL engine, to go process all available API methods. So everything that's public that returns a non-void value and that doesn't require any kind of argument or parameter other than context. That's a bit of definitely a wild card effect. It can have a time, take an amount of time to resolve. It's not something that you would use on a typical basis, but maybe if you're trying to figure out what methods would return the information you're looking for, it could be something maybe useful to try. The other thing with the projection is that we can assign an alias to the columns, and the framework or the BQL engine will automatically assign a name to each column for the items in the projection. And you may find that the names are cryptic, or you just don't like what the default names are. So you can use the keyword as, and then in single quotes, enter a string, and that's going to be the header for that column that you want to see displayed in the table. All right. So let's go back and take a little bit of a look at this. And whenever you're using the query builder, you can save queries here, by the way, and you can do that and then use this drop-down selector and pick from those previous queries. So when you have a query configured in the query builder, you can click the save icon here. Then it allows you to enter a name that you want to assign, and you can also see what that query actually looks like here in this field editor as well. So when we don't specify a projection in the query builder, you'll notice that it enters the asterisk character there for the projection then. And when we run that query, then, like I said, what we're going to see here is the get slot path method. So that's going to show us the slot path to each of the control points it found under the BACnet network. The toString method, which is what the developer wants us to see whenever we drop this thing on a PX page or we're doing a query like this. just information about the component. And then I'm also going to see facets property and a proxy extension property. And the reason for that is that if we look at the B control point, we'll see that it has a facets property and a proxy extension. So we get the toString, the get slot path, and then the two properties from that component. If we were to change that query to look for just the numeric points, for example, all numeric points, so I'm looking under the BACnet network for numeric points, again, not specifying a projection, we'll see we still get the slot path and the toString and the facets, but we also get the out slot as well as the proxy extension. So the out slot is actually defined on my numeric point, right? The numeric point. So we have the out slot here, but we also have the facets property and the proxy extension property, which come from the B control point superclass. So that's why we're seeing those three properties with that query. We can also do some queries where we want to specify a projection. And let's show that, I guess. Well, take a step back. We'll do the other special cases real quickly. If I hit Control L and open up my dialog here, and I can look at this, you can see that the asterisk character is there. So if I change that to all, for example, or I delete all and just do a blank projection, and this will take a little bit longer to return. And you'll notice now that there's a really small slider here because there's a lot of columns. And a lot of these are not going to be useful, right? But again, this is sort of a wildcard test is saying, hey, what's all the information that I could get from this numeric control point? And you could certainly scroll across and look for information maybe that you're looking for. Maybe this value with facets jumps out at you and you say, oh, well, that's the method that I didn't know the name of that will return some information on the way I want to see it. Now, using the query builder, we can look for all BACnet points, all numeric points maybe under the BACnet network. We'll just change this to all control points, I guess. And in the middle section here where it says choose columns, this is where you can specify your projection. And with each of these items represents a column in the result set. And when you do the drop-down selector here, you'll see that there are a few items that you can pick from. Some things that might be helpful, like name or parent or things like that. But this is certainly not an exhaustive list of things that you might type in here. So in this case, I might want to just say something like, say parent.name. So I'm saying essentially get parent from the control point, which is the points container, get the parent of the points container, which is the air handler, and then get its maybe display name. So this other field editor, say displayed as, this is where I set the alias. And then we could also say name as point, perhaps. So that's get name from the control point. Remember, each of these column expressions are being resolved against the item, the object that's returned as the row. So in this case, we're looking for control points. So these methods are all being called against a B control point. And then we can say value with facets as value. So these are the aliases of our column. When I resolve that, we'll see then we have three columns in the projection that we specified. And we can look at the, again, look at the syntax here without the query builder itself, just looking at the ORD path. I can see that my base ORD is the BACnet network and the extent is from control point. So each row in the result is a control point. And for each of those rows, the column expressions are going to say, get the parent, then get the parent of that, so get the grandparent essentially, and then get the display name from that. And we're going to alias that column as zone, and then we're going to say get name against the control point. We're going to alias that as point, which is our second column, and then we're going to call the get value with facets method, and we're going to alias that column as a value there. So that's how that would look working from the BQL query builder. There's different ways that we can certainly do these kinds of things. And this is an example of doing an arbitrary expression. So looking at this, we'll open up the ORD dialog. You can see in this case, we're using an aggregate function calling max on the out dot value. And then we have another expression here, which is getting the out dot value. So that's get out dot get value. And then I'm multiplying that times 100. And I'm using an alias as calculated here to title the column. And then just showing that you can do just arbitrary math without even reading values from something in the station if you needed to. Obviously, there's not much point in just displaying 3 on every row, but just demonstrating that these expressions can be mathematical as well as path expressions in aggregate functions. We'll talk more about aggregate functions in a subsequent video. Okay. One other thing I was going to talk about real quickly is the projection for histories and alarms. When we do have a query, a BQL query against a history, and particularly if I'm using the BQL query builder, then without specifying a projection, just like against the station space, what you'll see is it will use the asterisk for the projection here. So in that case, when you query a history, particularly, I would say a numeric trend or Boolean trend, right? We're going to get timestamp, trend flag, status, and value are going to be what's returned. And a couple ways you can kind of understand this or get at this is if we get rid of the history ID again and say from sys.histories, already showed you this, but just emphasizing that when you're looking at a numeric history like supply temp or space temp or whatever, then we can see the schema over here, and we'll see timestamp, trend flag, status, and a value. So those are the columns that get returned because that's the schema that's available from that history. And that can vary a little bit depending on the type of history. So another way that you can kind of look at this is if you look at maybe the history summary view on the particular history, you'll see the record type. So in this case, it's a history numeric trend record. If I was looking at some other history here, like the audit history, for example, we'll see that that's a history audit record. Or if I look at the security history, then it's going to be a history security audit record. Or if we look at the log history, then it's going to be a history log record type. So if we go to the help and we take a look at, in this case, maybe the numeric trend record, we'll see, particularly with the inheritance flattened anyway, we'll see that there's a timestamp, property that comes from B history record. There's a trend flags that comes from B trend record, a status that comes from B trend record, and then a value property that actually comes specifically from the B numeric trend record class. So there will be getter methods, that are public. So for example, if we scroll down here and look at the available methods, and mind you, the flatten inheritance is on. In this case, if we scroll down, we should see there's a public method that returns a babs time value. It's called get timestamp, and it doesn't take any arguments. So we lowercase or drop the get, lowercase the t, get rid of the parentheses. So get timestamp just becomes timestamp as the job of a method to call to get the timestamp from this B numeric trend record. So you'll also see that there's a get status method, which gets the status. There'll be a get trend flags method that gets the trend flags property from it, and so forth. So that's how I know what to type into the projection if I'm working with a history that I want to. And in the query builder, just like with the points, when we're querying for a specific history and we want to specify a projection, then you can just add the columns that you want to use, and then you're typing in the names of those schema items that we want to see included in the projection of the query. And we can obviously alias the columns as something differently, but that'll give us just a timestamp and value instead of having the status and the trend flags as well. When we talk about the alarm database, when we query the alarm space, then I already showed you this as well, but the items that get returned in each case here are going to be alarm record type. And I suppose there's a couple different ways that we could try to understand this. One way might be to just say that we want to display the type from each item that's in the row, and then that tells me what the type of that item is, so I can see it's an alarm record from the alarm module, so a B alarm record, or just understanding how the Niagara system works in the alarm database. So if we go to the help and I look at the alarm record, then we'll see that there's a lot of different properties that are available on an alarm record. Things like the timestamp of when it went into alarm, the user who acknowledged it, the UUID of the alarm, is acknowledgement required, when was it last updated, the alarm data property that stores lots of information. And again, when you look at the help document here, you'll see these public methods that like public get alarm data, which returns a B facets property that has all the alarm data facets, key value pairs in it. Or there's methods for getting the timestamp or getting the UUID and so forth. So whenever you're querying against the alarm space, if you want to specify a projection, which can be done through the query builder here as well, or using just the Control L dialog, or in an ORD field editor in a PX view, then you can certainly do things like timestamp as a timestamp, alarm data dot source name as source here, for example, or I might do something like alarm data dot msg text as message. So these are just the Java API methods, like saying get alarm data and then get message text, which is saying get the value from the message text key that's in the alarm data facets. So these are just calling those API methods, and then it's displaying the information in the projection. So B alarm record, or B numeric trend record, or B Boolean trend record, whatever the case might be for the type of history or the alarm database that you want to query. That's where you go look for help on the API methods that are available for your projection. So I know I said I was going to cover the predicate as well in this video, but just looking at how much time has already elapsed, I'm going to go ahead and cut this video off in the interest of keeping them a little bit shorter and more digestible in small time periods. And the next video will get into the predicate, into aggregate, and scalar functions as well. So hope you enjoyed the video, learned a little bit about base ORDs, extents, and projections, and a little bit more about the Niagara help system. And stay tuned for more information on BQL.